Okay, let's see how this works. This is going to be a video for year 10 science modality, both my chemistry and my physics groups. I would like you both to try a basic stoichiometric problem. While we do this, please focus, concentrate. Remember that this is a video. You can pause it or stop it at any time by pressing the right button, which means I'm going to read the problem, then you should stop the video, try it, do it, solve it, then you come back and see the tips. Franca, stop talking to Anastasia, please, okay? Okay, the problem reads, camellos, store the fat tristerin, just una grasa X, in the hump. Besides being a source of energy, the fat for the camels is a source of water, because when the fat is burned, the following reaction occurs, and you should know the reaction. It's a basic reaction about burning something, in this case by breathing, therefore making it react with oxygen to produce carbon dioxide and water. I'm going to show you now the reaction. I'm going to read the problems. You can find the text anywhere in the site, so please try it, then continue watching this. So let's see the reaction. The reaction is 2 moles of the tristerin fat, which is carbon 57, hydrogen 110, oxygen 6, react with 163 moles of oxygen, and they produce in gaseous state, the fat is solid, and they react to produce 114 moles of carbon dioxide, gaseous state, and 110 moles of liquid water. Now, there are 5 questions. You can read them in the site and do them. First one says, you cannot read it here, I'm going to read it loudly, at STP, standard temperature and pressure, what volume of oxygen is required to consume 0.64 moles of tristerin? And this is the basic idea. First, to clarify an issue. Standard temperature and pressure is 0 degrees Celsius and normal pressure, which can be said 1 atmosphere or 101 kilopascals, or just rounded up to 100,000 pascals, or 101 actually should be, but 101,000, but it's basically 100,000 pascals. And RTP, which is what the IG uses, is room temperature and pressure, the same pressure, normal atmospheric one, but temperature is 25 degrees Celsius. So we are going to work in the first question with standard temperature and pressure. What is the volume of oxygen that we need to consume 0.64 moles of tristerin? And if you check the reaction, it's basically written there. I mean, it does say there that 163 moles react with 2 moles of the fat. So we need 163 moles of the gas to react with 2 moles of the fat. Now the question is, what's the volume of oxygen that we need for burning 0.64 moles of the fat? That's very simple, because I have an X, I don't know the volume of the oxygen to react with 0.64, but I have the information in the chemical reaction, which says that 163 moles of the fat will produce 2 moles of the fat. Now those 163 moles of the oxygen are moles, but I need a volume. Well, every mole is 22.4 liters. That's the molar volume for any gas at STP, standard temperature and pressure. So if I multiply 163 times 22.4, I get the volume of oxygen, which is this volume, to produce 2 moles. What's the volume I need for 0.64 moles? Well, X, so X is 163 times 22.4 times 0.64 divided by 2, which is times divided by So we get the X. That's question 1. Of course, the answer, because I'm looking for a volume, will be in the unit I'm using for the volume, in this case liters, so this number will be in liters. I don't like liters. I'm a physicist, or actually work in physics more than in chemistry. Therefore, instead of liters, we should use cubic decimeters, which is the same equivalent unit, but doesn't matter. Then, we have more questions. I want you to read them and try them. But number 5, actually, reading question E, says, if we know that the camel has produced 1 liter of carbon dioxide at the temperature of the desert, let's say 45 degrees, what is the water produced? Now we have a problem, because now we cannot use these reactions, because these reactions talk about, well, we can use them, but we need to be careful. The volume given here for a gas is at STP, standard temperature and pressure, and now we have a different temperature. So we need to do something. And we are going to, I'm checking, okay, well, it doesn't matter. Basic idea is the following. 1 liter of carbon dioxide, in this case, is being produced at 45 degrees Celsius. We need to know it's not the same as 1 liter at, and I'm using now 25 because I'm going to use for this problem RTP. RTP is room temperature and pressure, where the room temperature is 25 degrees Celsius, and for that the molar volume is said to be 24 liters of any gas. Now we need to convert this gas from 45 degrees to 25 degrees. And we know this. PV divided by T is always a constant, which means for any gas, the product of pressure times volume divided by temperature is always the same number. So, in this case, pressure is the same, both at 45 or at 25. We're talking about atmospheric pressure. Therefore, we don't need to use the pressure, and we just get the equation saying volume times temperature is a constant, and therefore what is 1 liter at 318 will be X at 294. What are those numbers? Well, Kelvin, guys, because we need to use the temperature in Kelvin. We can never use these sort of equations with the temperature in Celsius degrees. So 318 is nothing else than adding 45 to 273. So this is the temperature of 1 liter of the gas carbon dioxide produced at the temperature of the desert, and that will be X, the real volume that we would get if the desert's temperature were room temperature, 298. Now, once we convert this 1 liter into the X that we need to find out, now we can continue with the equation saying, if this reaction says that we produce 114 moles of carbon dioxide, and that equals the production of 110 moles of the water, and we want to find out how many water is being produced with 1 liter of carbon dioxide, we need to know these 114 moles of carbon dioxide times 24 liters will be the volume of carbon dioxide that we produce when we produce 110 moles of water. Therefore, that volume coming from here, which is what we really produce this time, will be X. Okay, hasn't been that easy, so I hope you followed. Try it now. In any case, email me the doubts. See you later, alligator.